Hey there. We're diving into the world of graphene today. You know, those articles you sent in about it really got me thinking. It's been like, what, 2 decades since they first isolated it?
Yeah, it's been a wild ride for graphene, that's for sure.
No kidding. It went from 0 to 60 on the height meter, right? And now we're finally starting to see it, you know,
Yeah.
actually do things.
It's a classic example of turning like a scientific spark into something that could really make a difference, which isn't always easy, by the way.
Totally. Okay, so for anyone who missed the memo, we're talking about this crazy thin material, like 1 atom thin, carbon arranged like, honeycomb style.
Right, and that simple structure is the key to all of its almost unbelievable properties. I mean, think about it. Stronger than steel, conducts electricity better than copper, incredible heat conductor, all that from something essentially two-dimensional.
And to think, they found it using, like, Scotch tape, peeling off layers of graphite until, boom, single layer of graphene. You almost picture them in the lab high-fiving over a roll of Scotch tape.
Well, the 2004 discovery by Novoselov and the team was definitely a light bulb moment, and that Nobel Prize. Well deserved. But you mentioned the hype, and you're right, the journey from lab bench to our hands. It's got speed bumps.
Big ones. I mean, graphene was going to be everything. Faster chips for our phones, bendy electronics, even space elevators. I mean, come on.
Yeah, there were some bold claims early on. It's the classic hype cycle at play. Graphene was the hot new thing, and everyone got a little carried away.
But we got to ask, if it was so revolutionary, how do we go from it's going to change the world to crickets? What happened?
It's not that graphene isn't revolutionary. It's more that it's, well, more complicated than we first thought. It's not a magic bullet, not a simple swap for older materials. It's a whole family of materials, each with its own quirks and uses.
Okay, so graphene is more like a whole category then.
Yeah.
What's that mean for actually using it?
It means we've got options, right? Like, you've got that pure single-layer stuff, strong, conductive, the works. But then there's graphene nanoplatelets. Think stacks of the single layers, good for toughening things up.
So not just swapping one material for another, but like picking the right graphene type for the job?
Exactly. You wouldn't use a hammer to tighten a screw, right? Each type has its strengths. And get this, the 20 years article, it had some wild examples of graphene we don't even realize is there. You said yourself it hasn't taken over yet, but what if it's already in your pocket?
Hold on, seriously. Now you've got me curious.
Huawei, they're using graphene oxide in smartphones already.
See, I figured it was still stuck in labs somewhere. What's it doing in our phones?
Heat management, believe it or not. Phones get hot, right? Graphene oxide, it's amazing at spreading that heat. Way better than what we used before. Keeps things running smooth, no frying your phone.
That's wild. Sneaky graphene, making our lives better without us knowing. So besides phones, where else is it hiding?
Speaking of unexpected, how about the shipping industry? Big cargo ships.
Okay, now I gotta explain this one. Graphene and, like, giant boats.
Barnacles, of all things. They stick to hulls, create drag, ship burns more fuel. Turns out, coat the hull with graphene nanoplatelets, it gets super slippery. Barnacles can't hold on.
So graphene paint job means less fuel, better for the planet. That's clever.
Right. It's understanding what the material does, then finding where it fits, even if it seems totally unrelated. And we're just getting started, really. Water filtration, aerospace materials, you name it.
Feels like each application opens up like 10 more possibilities. But come on, I got to imagine there's roadblocks too, right? Before every phone has graphene in it, what's holding it back?
It's exciting stuff, but yeah, there's a difference between the scientists saying, look what we made, and it being in, every product, right? What are the hurdles here? Graphene's not on everything yet, so what's the holdup?
That's the billion-dollar question. And it's a common one with new materials. Scaling up, making enough of it, that's often the biggest hurdle. Graphene's no different. What makes it so tough, specifically?
Well, remember how we talked about making it the same way every time? It's not enough to make a tiny bit in a lab, right? For industry, for it to be useful, you need tons of it. And it all has to be identical, reliable, every single batch.
Like following a recipe, you might get your cake a little different each time, ovens being weird, whatever, right? Now make 1,000 cakes. All got to be perfect. That's a whole other thing.
Perfect analogy. And with graphene, it's not just making it, but the structure, that honeycomb pattern, even tiny flaws mess it up, change what it can do.
The 20 years article, they said there was a reproducibility gap early on. Is that what they meant? Like, scientists could make it, but not consistently.
Exactly. Back then, it was all about, can we do this at all? Pushing the limits. But if a company wants to use it, they need instructions they can trust, not, well, sometimes it works.
So how do we fix that? Bridge that gap between, wow, cool science, and here's how to make a million tons of it.
That's where research and industry got to team up. We're seeing that happen, which is good. That Beyond Lab Benches article, they talked about companies tackling this head on. Graphenia, they're doing big things with large wafer transfer. That's key for electronics.
Sorry, break that down for me. What's special about what they're doing?
So picture this.
Hmm.
You've made your graphene. It's on some surface, but you need to get it onto the thing you're building, like a chip, without ripping or tearing it. That's the transfer. Graphene has figured out how to do that with big sheets of graphene onto those silicon wafers they use for electronics really precisely.
Instead of tiny pieces, it's like they can unroll a whole sheet of perfect graphene onto the chip-making stuff.
Exactly. Way faster, way more efficient if you're trying to, actually mass produce things. And then there's Paragraph, going a totally different route. They're growing graphene directly onto devices using this MOCVD thing.
Sounds awfully complex.
It's pretty high tech, yeah, but basically, imagine spraying the ingredients for graphene as gases right into a chamber where they land, and bam, they form graphene right where you need it. No more separate transfer step.
So they skip a whole step, build it right in from the start.
Mm.
That's amazing, but what's the practical upshot here?
It means more complex gadgets, things with graphene built right into them from the get-go, sensors, maybe even totally new computer parts, who knows?
This is giving me hope. It really seems like we're at that turning point, going from like science fair project to something real.
It does, and the best part is people are working together on this. Places like the Graphene Engineering Innovation Center, they're like matchmakers, getting scientists and companies talking, giving them the tools to build this stuff.
So it's the material and the support system around it. That's how big changes happen, huh?
100%. And as that system grows up, we're going to see uses for graphene we haven't even thought of yet, I guarantee it.
It's like you said at the start, it's not always a sudden revolution, right? It's slow, steady progress, people building on each other's work. And that's how we get from a lab bench to, well, maybe not flying cars yet, but something just as cool, changing the world bit by bit. Thanks for joining me on this deep dive. It's been enlightening.
My pleasure. Graphene's got a bright future, that much is for sure.